In this question, if R tau is an autocorrelation function of a real WSSXT, then it is even and R tau is smaller or equals to R0, and its Fourier transform is non-negative. And if S omega is a power spectrum density of a WSS process XT, then it is non-negative. So for the A question, and Fv equals to a to the power of negative the absolute value of v, and we can find that it is obvious that Fv is an even function, and also e to the power of negative the absolute value of v is smaller or equals to a to the power of negative 0, and also e to the power of negative the value of absolute value of v. The Fourier transform is 2 divided by 1 plus omega to the power of 2, and we can also find that this part is non-negative. And so Fv may represent an autocorrelation function, and we use omega to substitute v when it equals to e to the power of negative the absolute value of omega. We can find that it is obvious that this part is bigger or equals to 0, so it may represent a power spectrum. In the B question, Fv equals to sin v to the power of 2 divided by v to the power of 2, and we can find that it's obvious that Fv is even, and when v approaches to 0, the value of sin v to the power of 2 divided by v to the power of 2, this part will approach to its maximum value, and we can use a L'Hopital rule. We can know that the maximum of this function is the value of this the maximum of this function is when v approaches to 0, it equals to 1. And also the Fourier transform of this function, the figure of its Fourier transform is this. It's a triangle, and the maximum value is 1, and it's between negative 2 to 2 in omega. And so it is obvious that this is non-negative. And so Fv may represent an autocorrelation function. And we use omega to substitute v, and we can find it equals to sin omega to the power of 2 divided by omega to the power of 2. We can find that it is obvious that this part is non-negative, and so it may represent a power spectrum density function. And in the C question, if V equals to 1, when V is the absolute value of V is smaller or equals to alpha, and otherwise it equals to 0. And so first we can find it is even. And we can also find the Fv is smaller or equals to F0. And the Fv its Fourier transform is 2 multiple sin alpha omega divided by omega. And we can find that this part alpha is a negative value, but omega can be negative. So this part is not it is not non-negative. And so Fv cannot represent an autocorrelation function. And we use omega to substitute V. It is obvious that it is non-negative, and so it may represent a power spectrum density function. And so this is a two question.